All right, so let me move on then to our final presentation of the day from NASA. We do have two guests from NASA. Their names are BreeAnn Stallsmith and Anna Cavalowsky. They're project administrators for NASA, and so they're going to be giving us an overview of Advanced Air Mobility Mission Strategy. So let me turn it over to BreeAnn and Anna from NASA.
Thank you so much to the AUVSI North Carolina chapter for inviting us to present here today. Just a quick introduction. My name is BreeAnn Stallsmith, and I work as a project administrator contracted to support NASA Aeronautics Research Institute, also known as NARI. Along with my colleague Anna Cavalowsky, who's presenting with me today, we work to support the AAM mission. It's a really exciting time to work in this industry, and we are excited to be working on this initiative for NASA. So I think to know about the inner workings of AAM, it's important to understand how we got to where we are. A large part of the success of this program is built off the past successes of NASA's Unmanned Aircraft Systems Traffic Management project, also known as UTM. The UTM project is developing and testing a highly automated system of traffic management of small drones flying in low altitude. The project itself started in 2015, and since then we have been following a crawl, walk, run approach to building and testing the UTM system. The program started early with basic system testing in rural environments, and each year we have added capabilities to the system and tested it in more complex environments. In the summer of 2019, NASA tested in the complex urban environments of Reno, Nevada, and Corpus Christi, Texas. The Nevada and Texas FAA designated test sites ran the tests from us and used 35 industry partners to provide the highly advanced drones and UTM services. What we see here is a picture of 4 drones flying over simultaneously over downtown Reno. The other picture shows 2 drones flying over Corpus Christi. So just to explain, it was basically trying to show a day in the life of what could be, from building inspections, news gatherings, package delivery. And we also used this to test the exercising beyond visual line of sight operations, rooftop takeoff and landings, flying between buildings, and reacting to different weather conditions. And the top right picture is actually of the Aerospace Operations Lab at NASA Ames, which monitored the testing and collected the data. So from this operations, we learned a lot about flying in cities and challenges with communications, GPS navigations, and safe landings, and many more things. But moving forward, results and technologies will be transferred to the FAA and industry for future implementation into the national airspace. Some things that have happened and will happen in 2020 as the UTM project wraps up. The results from last summer's testing have been analyzed and documented at various events such as SciTech 2020, Aviation 2020, and numerous NASA technical memorandum. Another thing to note is that NASA is collaborating with the FAA on UTM Pilot Program 2.0. The testing at Virginia and New York FAA designated test sites will commence soon, and several of the same industry partners that participated in TCL4 have already signed up to be a part of UPP 2.0. And also providing the input to standards groups on UTM performance and operations. What does this mean for the future? The concept of operations and architecture demonstrated by UTM in low altitude for small UAS is being applied to research of other flight regimes and emerging markets in aviation, from thin short haul, high-class e-traffic management, space traffic management, and probably most notably, urban air mobility. As I stated before, the UTM project has been instrumental for the AAM ecosystem. NASA is able to use UTM as a roadmap to hopefully be able to accelerate the development of safe high-volume AAM flight operations. And so with that, I want to hand it over to my colleague, Anna Cavalowsky, who will be able to give you a little bit more of an in-depth look at the AAM ecosystem and give you a little bit more detail about what NASA is doing to further that mission.
Thanks, Bree. So as Bree mentioned, one NASA project that UTM is feeding directly into is advanced air mobility, AAM. And the AAM mission is to develop and implement an integrated plan for enabling emerging aviation markets that will provide substantial benefits to the U.S. public and industry. This includes rural and urban applications, that's cargo transport, people carrying, and there's definitely a focus on electrification and automation. With considering all of this, naturally, urban air mobility is considered a challenging use case, but with a very high benefit. So when we think of the AAM project and its framework, we look at 5 pillars. Each pillar represents a key area of the AAM ecosystem. Now, pillars 1 and 2 are going to be aircraft focused. So that's vehicle development and production, and individual vehicle management and operations. Then pillars 3 and 4 are going to be focused on airspace. So that's airspace system design and implementation, and airspace and fleet operations management. And then lastly, we have pillar 5, and that's going to be all about community integration, which works with societal integration and acceptance of UAM operations, but also other emerging AAM markets. So with each pillar also comes barriers or challenges that must be addressed to enable the AAM mission. For example, with aircrafts, we look at developing a more sustainable manufacturing and supply chain, or we think about vehicle certification. Airspace, we're looking at safe airspace operations, taking into a lot of consideration of the UTM research and development. And with community, you look at public acceptance, but you also have to see the challenges that come with local regulatory environments and those liabilities. And then on top of that, there's cross-cutting barriers that impact all 5 pillars. And those are going to be noise, autonomy, certification, things that really impact aircraft, airspace, and the community piece. So when you take into consideration both that framework and those barriers, NASA then creates a representative timeline of how to unlock the ecosystem through maturity levels, or what we call UMLs. And generally, the maturity levels lay out a path from today to a future state. And that future state includes increasing in the numbers of aircraft flying, the complexity of operations, and the level of autonomy. Now, when we look at what NASA's aiming for and focusing on, it's really reaching what's shown on the screen as UML 4. So that's helping to achieve UML 1, 2, 3, and 4. And 4, when we think about it, we think of medium density operations. So first, what is medium density? That's going to be hundreds of aircrafts, tens of vertiports. Then we look at medium complexity. That's going to be operations in the urban core that has limited physical separation between vertiports and people and property. It's also going to have visibility independent operations. And we look at responsible automated systems. So that's comprehensive automation. That's autonomous situation awareness and collaborates with the pilot to identify and manage hazards. At the same time as safely and appropriately executing flight and contingency operations. It's a fully automated system. Now, why are we focusing on UML 4? There's multiple prongs to that, but the first is market studies show that this is where the industry can reach profitability. That's looking at 30 to 60,000 of people flying in these vehicles per day. That's 100 to 200 aircrafts flying over a metropolitan city, approximately 20 vertiports in those cities, and takeoff and landing every 30 to 90 seconds at a vertiport. That's a very extensive transportation system. So that's where we could reach profitability. Now, there's also a high level of industry interest in those capabilities. There's a lot of excitement around that right now, and we have a lot of companies that are investing in making these capabilities possible. But the last piece, and one thing NASA's always thinking about, is where can we reduce risk? And to achieve UML 4 is hard. This really is the next step in aviation that is completely different than anything we've looked at before. And NASA wants to invest there so that we can really help industry be able to achieve and enable AAM. So we recognize this is a complex ecosystem. From everything we laid out there, it's going to be a journey, but we want to work with you and the community to make this a real and practical transportation system. So at the end of March, we launched the AAM ecosystem working groups. Now, through these working groups, our goal is to foster collaboration and help accelerate the necessary capabilities to enable the AAM ecosystem. Now, we understand there's a lot of other working groups out there, And our intention is not to duplicate their efforts, nor do we want to duplicate the amazing efforts of the associations and everything that people like AUVSI are doing, which is collaborating with the community, working with different standards organizations. They're helping to promote what needs to be the next level of R&D research. We don't want to duplicate that, but we want to amplify those efforts, and we want to work with them to see what are the existing gaps and how can we help decrease those gaps and really help push some research there and collaboration there. Now, these working groups will be broken down into 4 groups. So we're looking at aircraft, airspace, and community, very similarly to how the big categories in those pillars. But we're also going to have a 4th group, cross-cutting. Now, the cross-cutting working group will include everyone that signs up for the working group, but will focus on those barriers that impact all 5 pillars and include the UAM community ConOps and national campaign. Now, these meetings will function very similarly as public working group meetings. So that means it's open to everyone. They'll come in, and we want to collect feedback and input to foster collaboration and work on gathering data and information to drive standards and really help move the big picture forward. Now, as mentioned in the previous slide, the AAM ecosystem working groups launched at the end of March. However, we anticipate the individual working groups, aircraft, airspace, community integration, and cross-cutting, to start in the first couple weeks of May. So through these working groups, NASA is developing the following tools. And we really look at these working groups as a source of collaboration, but also input to build these products out. And the first is going to be the Book of Requirements and Guidelines, or as we like to call the Borg. Little nerdy, I know, but it's catchy, I promise. But the Borg is going to be a set of requirements and guidelines to ensure coordinated development of the entire ecosystem. And that's, again, consisting of vehicle airspace and that community piece, the infrastructure. Now, the book also will focus on reaching UML4, but it's going to contain a broad spectrum of elements. That's going to be pieces like the community ConOps, use cases, validated system requirements that have been validated by standards bodies and the FAA, regulatory guidance, recommended practices, methods of compliance, even just evidence and supporting data that leads to recommendations. The idea is that this book is really all-encompassing and a tool the industry can use to build out their business models or create specs, just kind of guide everything to enable this ecosystem. And it's going to be based off of a model-based system engineering MBSE framework, approach, and system. So it'll be able to feed into a lot of what industry is already doing. Then to build off that Borg, we're looking at an ecosystem scorecard. So this is going to pull from the AAM milestones, the maturity levels, the Book of Requirements and Guidelines, and it's going to be a measuring tool, a way for the industry to judge their readiness and make sure that we're hitting the capabilities and achieving the capabilities we need to make AAM missions possible. And then the last piece that we're building together is going to be the system architecture. So this will explore viable system concepts, including target levels of safety, interoperability, user attributes, community integration. They'll look at this with trade space exploration, and will even hopefully develop critical technology prototypes to assess feasibility, scalability, cost, regulation, and all that's involved in advanced air mobility. Now, as you see, all these tools are very intertwined, and the goal of these working groups is to help develop these tools and really create a full integrated picture of the AAM ecosystem as a whole, so that aircraft, airspace, and community piece. And we see that this long-term, or our goal is long-term, that these will become open source tools for the community to utilize, feed into, and help accelerate the realization of AAM missions. With that, I'm going to pass this back to Bree so she can talk to you about some other amazing tools that NASA is working on.
Thanks, Anna. So yeah, to kind of build off of that, I think you can see why not only NASA and the ecosystem, but many cities are really excited about the prospect of advanced air mobility and urban air mobility. And because of this, it's going to provide a lot of opportunity, but it's also going to provide an alternative source of transportation and hopefully open up the major metropolitan cities more so than they are now. However, local municipalities, as well as the city planners, need a tool to determine where the best place is to build these vertiports that they're going to be needed for UAM, and guidance on how to design these specific UAM routes. So for this reason, NASA is working on developing a regional modeling and simulation tool that will evaluate the functionality of vertiports based on attributes specific to the city in need. So this would enable us to take a specific city's geographic information and environmental concerns and then visually map it to determine total suitability. And this can be changed city to city so that depending on who needs that data, we can work with them to provide what is needed. So as you can see on the slide here, these are just a few of the various factors that we are looking at and taking account for in the tool. There are many variations of the ones that are obviously pretty common, noise, zoning, ridership, etc. However, there are quite a few new ones to consider as well. For example, vertiport certification requirements. And then later, we have to take into consideration the eVTOL vehicle and battery charging models. So overall, this tool gives cities the ability to maximize opportunities available as the AAM ecosystem develops and grows. So how does this all fit together? The goal of the working groups is to accelerate the development of safe, high-volume AAM flight operations by bringing together the broad community involved in developing this new capability. The feedback and inputs received in the working groups will be used to create the AAM system architecture, the Book of Requirements, or BORG as Anna stated, and the ecosystem scorecard. And long-term, this will become open source tools for the community to utilize and to help realize the AAM mission. So with that, I again want to thank the AUVSI North Carolina chapter for inviting us here to present. On the slide, you will see both Anna and my contact information. So if you have any questions or feedback, please feel free to reach out. And we look forward to working with you on this mission in the future.
Thank you so much to BreeAnn and Anna from NASA for joining us here and for sharing their insights there on that topic. That was really, really informational, and we really appreciate them joining us today. I want to bring back in Romeo and Joseph as well, just to wrap things up with a couple of questions that we've gotten from the audience, as well as just some follow-up questions from their presentation. So Romeo, I want to start off with a question for you, and then we'll get Joseph's feedback after that. But Romeo, you talked a lot about what you learned from the Nepal earthquake back several years ago and the way that that affected things moving forward, how you adjusted, and maybe what the industry and what the marketplace learned from that experience. Kind of talk me through what you think some of the lasting lessons from this experience as we deal with COVID-19 will be for the drone industry and for what you do at DJI.
That's a very good question. You know, once we conclude this project and we're going to start working on the after action report, I think a lot of things will come to shine. And I think right now, personally, I would say this morning I was on a webinar with Interpol, which is the international police organization covering 194 countries, and the topic was drones in COVID-19 response around the globe. And we had countries from across the world talk about their experiences with drones. Very interestingly, there were very little negative backlash or community concerns in the majority of those countries reported. There was one incident in the UK where a police department was trying to enforce social distancing in a park that pretty much only had 2 or 3 people in it, and that kind of created a lot of media attention. But what we're seeing here in the United States is very, very different. And that leads me to believe that the public has still not trusted enough the drone technology being used for public safety purposes that fear of Big Brother is watching is still very prevalent. And we as a community, as well as the public safety, has to continue to be transparent with their drone usage. And I see a lot of great examples of departments that make available their data on when they're using drones and what it led to. For example, Marin County Sheriff's Office in Northern California, every quarter they release a report to the public of all of their drone activity and what happened and what was done, if there were any arrests, what was the scenario. And that kind of transparency is key, especially right now. You know, I've had the privilege of growing up in Switzerland and in Europe, and now I've been spending 20 plus years here in the US. So I can see a little bit of both sides. And we really here in the United States put a lot of focus on our freedoms, and that's extremely important and has to be taken into consideration when we create these new use cases that could potentially raise eyebrows with the population. So I think that's one of the biggest lessons learned so far.
Absolutely, and I want to pivot to Joseph as well to get his thoughts on this from Zipline's perspective. Just where do you feel, Joseph, will be some of the lasting lessons and some of maybe the big takeaways and things that will change in the industry moving forward after COVID-19? What will be learned during this pandemic, and how will things look different after it?
Yeah, it's a great question. I mean, I think we're finding out very quickly how to move fast. We're already moving at next speed, but the partnership between regulators and industry, where those pain points lie when we're trying to respond to something like this and move at like I said, breakneck lightning speed. So breaking down those barriers and seeking a path forward has been one of the most tremendous learning opportunities that I have and Zipline as a whole has had. So, and the speed that we are moving, it's start really kind of bears in terms of things that we would like to have for our, inevitable US launch, and just has been a forcing function to get those answers sooner rather than through unfortunate circumstances. We're doing that. But it's work that nonetheless had to be done. So in a way, through these unfortunate circumstances, it is expediting some work that, and unlocking certain answers that not only Zipline needs, but others need to progress us, to a scalable solution for beyond visual line of sight commercial operations. So, it's unfortunate, like I said, unfortunate, but a tremendous amount of value is already coming out of this just based on the relationship that we're having with the FAA and other industry partners.
Yeah, I think you're absolutely right. And I think sometimes in times of great challenge is when we are able to use that time to really push things forward, because the situation necessitates that progress and that growth. And so I think you're absolutely right that sometimes these times of great challenge really do produce some innovation and the ability to ask hard questions and to move things forward as a result. Romeo, we got a question from Edna in the audience who asked, when it comes to drones in flight, have they resolved how other aircraft and helicopters will be able to see them? Can you answer that question for our audience?
Oh, that's another good one. So what we at DJI decided to do is to integrate ADS-B receivers into our technology, into our consumer and enterprise technology, so that the drone operator gets awareness of his or her surrounding by a message that pops up. ADS-B is being used as a transmitter on crewed aircraft. And so if a crewed aircraft, a helicopter or fixed wing comes close to the operation area of a drone operator, a message will pop up, and on the map you will be able to get additional information on where that aircraft is. The drone itself, as it stands right now, does not send a signal out to the world, meaning other aircraft cannot see the drone, or ATC, the control tower, cannot see a drone flying. We deliberately did that so that we're not overwhelming the system, but give the operator, the drone operator, the data that is available. Obviously, the UTM project to integrate drones into this larger airflow framework is going to be the future. But as of right now, it is the drone operator's responsibility to know his or her surrounding and yield to crewed aircraft. It's just a tool that can potentially alert an operator.
Absolutely. Well, that's going to do it for this presentation. Thank you all so much for joining me. Thank you to Joseph, to Rachel, to Romeo, and also BreeAnn and Anna from NASA. Thank you all so much for being here today, and thank you also to just our fantastic viewers who joined in, who asked questions, who participated in this workshop today, presented by AUVSI's North Carolina chapter and Market Scale. Thank you all once again. Until next time, have a great day, stay safe, and we'll talk again soon.